Okay, so in this video we're going to discuss polar curves. Okay, so polar curves typically have the form r equals some function of theta. Okay, so we usually write that as r equals r of theta. Okay, so before we go into more detail about this, uh, let's look at one example where this isn't true. So one simple curve is going to be theta equals a constant. So let's take theta equals 1. Okay, so if theta equals 1, that means we're taking all points where theta equals 1. Okay, so 1 should be, uh, what about a third of the way to pi? So maybe about there. So everything along this line here, infinite in both directions. Again, remember there's no restriction on r. R could be positive or r could be negative. Okay, so this is the curve theta equals 1. Should look like this. This is every point where theta is 1. Okay, so the other very basic example would be r equaling a constant. So let's take r equals 2. So in this case, there's no restriction on theta. So theta can be whatever we want provided r is 2. Okay, and this should be a very familiar shape if I can draw it. And I really can't. This should be a circle of radius 2. Okay, so that should be a circle of radius 2. And one other very simple idea is what happens if we have a line. Okay, so a line. So theta equals something is going to be a line always through the pole. But what happens if we take any line? So any line, if you recall, in Cartesian form is going to be ax plus by equals c, where both a and b are both not 0. Okay, but recall that x is going to be r cosine theta, and y is going to be equal to r sine theta. So what we're going to do is we're going to substitute these in to our equation here. So we get a times r cosine theta plus b times r sine theta equals c. Okay, but as I said right at the beginning, we always want to think about this as r equaling a function of theta. Okay, so we can factor out an r from everything on the left-hand side. So we get r times a cosine theta plus b sine theta is equal to c. So the equation of a line in polar form is going to be r equals a constant over a constant times cosine theta plus a constant times sine theta. Okay, and this is how we write any line in polar form is going to have this form. Okay, so there's a few other common curves you should know in polar form. So let's look at a couple of these. So we want r equals 2 cosine theta. Okay, so what I'm going to do is I'm going to start by making a table, and then we can plot the points. Okay, so we're going to have our theta, and we're going to have our r. Okay, so theta is the independent variable. We choose theta, we get the r value out. So we can start at 0, and if theta is 0, cosine 0 is 0. Then we can go to pi over 6. Cosine pi over 6 is root 3 over 2, so this should be root 3. Oh my, I totally messed this up. Cosine of 0 is 1. 1 times 2 is 2. There we go. That makes more sense. Pi over 4, cosine pi over 4 is root 2 over 2, so this is root 2. Pi over 3 should be cosine of pi over 3 is a half, so 1/2 times 2 is 1. Pi over 2, now this is going to be 0. We then go to 2 pi over 3, and this should be negative 1. 3 pi over 4 is going to be negative root 2, and 5 pi over 6 is going to be negative root 3, and we need one more, and that's pi, and that's going to be negative 2. Okay, I don't need to go any further, and we'll see why this is when we draw our picture. Okay, so we're starting off at the point 2, 0. So r is 2. Theta is 0, so that's at this point right here. Next we have theta equals pi over 6, r equals root 3. So root 3 should be a little bit smaller than 2. Theta equals pi over 4, r equals root 2. Theta equals pi over 3, r equals 1. Should be about there. And theta equals pi over 2, r equals 0 is the pole. Then we have r equals 2 pi over 3. Our theta equals 2 pi over 3, r equals negative 1. So we're going 2 pi. In the 2 pi over 3 direction, we're going negative 1, so that's actually down here. Three pi over 4, we're going to be at negative root 2. 5 pi over 6, we're going to be at negative root 3. And now at pi, remember we're going negative 2 in the pi direction. Pi is over to the left. So negative 2 in that direction is back where we started. So this curve is actually going to be a circle that's going to be tangent to the pole over on the right-hand side. Okay, so this is one of a family of curves. So this is r equals 2 cosine theta. Okay, if we change this ever so slightly, so if we take r equals negative 2 cosine theta, the only thing that this does is you're going to end up with a circle now on the left-hand side of the pole rather than on the right-hand side of the pole. Okay, and again, our diameter here is 2. Okay, so rather than the radius of the circle being 2, the diameter of the circle is 2. Okay, relatedly, if we take r equaling 2 sine theta, that is also a circle tangent to the pole, only it's a circle facing upward, and r equal negative 2 sine theta is going to be, again, another circle tangent to the pole, but this time facing down. Okay, so if r has a negative, so if it's r cosine theta is a circle to the right, our sine theta is a circle facing up, and then if it's negative, it's reversed across the pole. Okay, one other basic curve is called a rose. Actually, I think we'll talk about the rose and one other curve in a separate video. So thank you for watching.